In the video, the baby does a very good job at recognizing the words even he cannot spell or read. It turns out that we can teach very young babies to read by simply showing them flashcards of the entire words. It's the same way that we teach the machine to read math as well. We show the image of the entire equation to network and let it learn by the time. In the project, we do only subtraction and addition of two single-digit numbers that gives positive results. Totally, we have 155 unique equations, and we produce 72 by 32 pixel image. In the training phase, we use 140 equations and held out other 15 equations for testing. For each equation, we produce 6,400 examples by transiting and rotating two numbers and the operator. We make sure that there are no duplicates in the dataset. Since we take 10% of numbers of examples in the whole training set to make validation set, we have 806,400 examples in training set, 89,600 examples in validation set, and 96,000 examples in test set. We use Lenet as the training network. Lenet is a network that's used to train on any dataset to recognize single digit, and now we train it to recognize equation and do math. The Lenet has 6 layers, which are 2 convolutional layers, 2 pooling layers, 1 fully connected layer, and an output layer. In the training phase, the accuracy easily reaches 100% when it tests on validation set after only 1,500 iterations. However, when we take the chain network up to 1,000 iterations to test the test set, which includes the example of equation that the network never seen before, the accuracy dropped to 11% on average. Since the accuracy is twice as guessing rate, which is 5%, we think that the network learns something, but not learn good enough. We cannot conclude anything for now about the network and math skill learning. We will do more experiments in the future by reproduce the data set, since when we first create the data set, when we do the transition, the different pixel of number between images is quite small, so the network may remember it. The overfitting may happen. That's why it did very well in the validation set, but very poorly in test set. We may increase the amount of different pixels of number in image and decrease the number of examples to eliminate the overfitting. Next step, we will apply batch normalization, which does a great job lately to increase the effectiveness of deep neural network. Batch normalization allows us to use much higher learning rates and be less careful about initialization. Batch normalization layer is usually below convolutional layer or fully connected layer, and above nonlinear layers such as sigmoid or 10H activation function layer. However, I also want to try to apply ReLU, which does a better job than sigmoid or 10H activation function. And when the network learns successfully how to do addition and subtraction of two single-digit numbers, we will teach it how to do calculation that give negative results, how to do multiplication and division.